Yay, it's Wednesday. Good morning, fifth graders. I need you to open up Kata Blog and add puzzle. Remember, today is experiment day. Wednesdays are our experiment days, so I love Wednesdays. We're going to do a tie-dyed milk. So we're looking at surface tension. We've talked about that last week. We did an experiment with surface tension last week. So that's what we're going to continue with our experiment this week, surface tension. Because remember last week, there was one way we can break those molecules apart. We can break that barrier. And what did we say we needed? We needed soap. So that's what we're going to take a look at this week, how soap can break the surface tension barrier. So your objectives today is you would demonstrate the property of surface tension and the effect that soap, a surfactant, has on the surface tension of milk. Students will apply soap to milk with the food coloring on the surface to visualize the effect of soap on the surface tension of milk. Now, this is an experiment that you could do at home if your parent would allow you to. And I really wish we could have done this at school because you really would like this experiment. So, first video and the only video. Go to Edpuzzle, and I would like for you to look at reducing surface tensions, a minute 15 long. And you guys, you've got to look at the videos. The videos help to explain things, and then come back to the PowerPoint. Surface tension. Liquids like water and milk have a property known as surface tension due to the cohesive forces of the liquid's molecules. Look closely at the edge of the surface of the water in the clear glass. They're talking about this right here. Do you notice how the very edge of the water appears to rise up side the glass? That's because the surface tension of the water is actually pulling the water away from the glass inward towards the center of the surface. Now, that sentence reminds me of something. What word comes to mind when we're talking about pulling inward towards the center? Correct, gravity. So that reminds me a lot of gravity. So we have water, surface tension, and we have milk, surface tension. So the water molecules, and what are the water molecules called? Hydrogen and oxygen, correct. So those water molecules at the surface, this is how they are, like this. Now, look at those water molecules below the surfaces. They look more like this. Remember, below the surfaces, that's when they're bonding. They're snuggling together. Okay, they're attracted to each other. So those molecules are bonding. This is why that bonding pushes the water up or pushes the milk up, and it doesn't roll down the side of the glass. Milk, like water, has a property known as surface tension. Something just ran across my mind. And you probably can guess the question I'm getting ready to ask you. What would milk be, a solute or a solvent? It would be a solvent. Very good. Surface tension can be thought of as a skin on the surface of the milk. It is created by the molecules in the milk bonding to each other more than the other things around them. So if I take a look at this diagram, because yes, you know I got to have a visual. This would be like the skin, like you have a skin on your body. So if I had a glass of milk and I have it overpoured like surface tension, that would be considered like the skin of that milk because that is the surface. So we're going to do an experiment today called tie-dye milk. Some of you may have done this before, and like I said, I wish we could have had time to do this in class. So you're going to be working with food coloring. Now, the food coloring, and by the way, I do know how to spell, but this came from a website from England, and this is how they spell coloring, by the way. The food coloring is less dense than the water, so it floats on the surface. I hear another vocabulary word. Actually, I hear two. I see one vocabulary and I see another vocabulary word. What does it mean to be dense? Right. It means it would be heavier. It would go to the bottom. And give me another word. Give me a fifth grade word for float. It starts with a B. It would be buoyancy. So I'm going to read that sentence in fifth grade terms. The food coloring is less dense. It does not go to the bottom. It's not heavy enough to stay at the bottom than the milk does, so it has buoyancy. It stays on the surface. And what do these areas represent? Remember, it represents the skin of the milk. So when I put the food coloring in my milk, or if you do it at home, when you put the food coloring in your milk, the food coloring is going to stay on the top because it's less dense than the milk. Something else you may have noticed is that the food coloring seems to float on the surface of the milk. This is because the milk has lots of substances dissolved in it, such as calcium. And you guys really should be drinking milk. I know it's when I have breakfast, a lot of you guys throw your milk away. And that's not a good thing. You need calcium. You're still growing. Your bones need that calcium. Anyway, I diverted. So let me go back. Something else you may have noticed is that the food coloring seems to float on the surface of the milk. This is because the milk has lots of substances dissolved in it, such as calcium, making it more dense than the food coloring, which is almost entirely water. You notice when we do things at school, and every time I have an experiment and I'm involving water, what do I add to the water? Correct, I add food coloring. And why do I add food coloring? We talk about this every time so that you can see what I'm talking about. So that's why we're using food coloring in the milk. We're adding food coloring in the milk. It's going to help you to be able to see how the soap literally breaks the barrier of the milk. Okay, so that's why we use food coloring. Food coloring also is just mainly water. It just have coloring in it. So therefore, it's obviously going to be less dense than milk because milk has things in it like proteins and fats and calcium. So therefore, it is heavier. It is more dense than the water. So here's our plate, and I'll show you this in more detail in a few minutes. Soap breaks apart the surface tension. So I'm going to put food coloring in like this. The food coloring is going to do like this. I'm going to drop it here, we're going to drop it here, we're going to drop it there, we're going to drop it there. Washing up liquid dishwashing soap is designed to break up the surface tension so the water can dissolve the fats and grease. Remember on the last video about surface tension, I showed you the greasy hands. That's what the liquid soap does. It dissolves the grease that was on the hands. It breaks the bonds of those molecules. This means that when you add the dishwashing liquid, the surface tension becomes weaker. Remember, it is a blocker. It is a blocker. So this surface gets hugely stretched by the milk. This hasn't met the dishwashing liquid yet. And where you see washing up liquid, this is what the Europeans call washing up liquid. What do we call it? We call it dishwashing liquid. The dishwashing liquid breaks the surface tension where it lands, allowing this surface to stretch hugely, causing the rest of the surface to shrink. So you're going to actually see one set gets wider and the other set will shrink, and you'll be able to see that. You'll be able to make that observation. And it's very, very pretty. It's really, really pretty. So the shrinkage pushes the food coloring downward. And what else brings things down to the center of the earth? Correct, gravity. So the shrinkage pushes the food coloring downward and it flows back up again, forming these beautiful patterns. So the food, when we put the soap in, the food coloring is going to go down. But why doesn't it stay down? You're so smart. It doesn't stay down because the milk has more density than the food coloring. So after it goes down, it pushes right back up again. And then it starts to make these swirls of all these beautiful colors. Because the rest of the surface is shrinking, it must be getting thicker. This pushes the food coloring downward, and there is a current below the surface flowing back towards the dishwashing liquid, pulling the food coloring along. It then floats back up to the surface, producing those beautiful patterns. Okay, so when soap is added to the milk or water, the strong bonds between the molecules are broken and the milk will start to move around. Okay, so they are blockers. They're blocking those molecules from snuggling and being close together. That is the job or the niche, I'm glad you remember that word, of dishwashing liquid or any kind of a soap. So here are your materials. I need milk, I need food coloring, I need dishwashing liquid. I need a cotton swab. I need a plate or something that's flat that can hold the milk. Newspaper is just so that if you have a mess, it'll go in the newspaper. You can use a tin pan if you're going to do, and it doesn't have to be a tin pan, it just needs to be something that's flat enough to hold your paper, your Xerox paper. But that's for our extra activity if you choose to do so. Now, I want you to go to Kid Blog and I want you to answer these two questions. Number one, what would happen to the food coloring when I drop it on the milk? Explain your answer. And number two, what do you think will happen when I put the cotton swab soaked in dishwashing liquid in the milk and the food coloring bowl? So those are the questions I want you to think about on Kid Blog. Okay? So it says answer before you watch the video. You guys, you've got to follow directions, please. You've got to follow directions. And go to Kid Blog. Answer those questions before you watch the video. Pause this PowerPoint and then come back after you have answered those two questions. Come back to this PowerPoint from Kid Blog. Okay, so you've answered those two questions, so let's continue. Here are our procedures. Number one, I'm going to pour enough of the milk to cover the bottom of the dish. Number two, I'm going to drop 1 drop of food coloring onto the milk. And number three, and I'm going to go back to this one. When I drop it in, I'm going to put one here, one here, one here, one here. And because we don't have corners, it's going to be round. So we have a circumference. I don't have a corner. I'm going to just drop it around like this. It's going to give it a chance to meet up and it all won't be concentrated in one area. And number three, I'm going to, before I start actually, I'm going to put my cotton swab in the dishwashing liquid to make sure it's fully saturated. Ding, 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 ding. I see another vocabulary word. Saturated. You want those molecules? We're going to oversaturate, over molecule the cotton swab with what? With dishwashing liquid. Why do I need the cotton swab saturated? I need enough dishwashing liquid to move or to block those water molecules that's snuggling tightly together. Then I'm going to touch the cotton swab and I'm going to put it in the center of this plate. Now, fifth grade, if you do this at home, and you'll notice that I do it when you see the experiment, I'm just going to put it down. I'm not going to move it around first. I'm just going to put it in one place. And then I'm going to put it in another place. Because remember, you have food coloring in 4 different areas of your plate or your dish, depending on what you're using. So the first thing I want you to do is just let it do it by itself. It doesn't need your help. The dishwashing liquid is going to do what it's supposed to do. So let the dishwashing liquid do what it's supposed to do, meaning break the surface of the tension. The food coloring will make its way to the dishwashing liquid. I'm not going to say too much because things I need you to observe. Now, after it stops doing what it's going to do, then you can start taking your cotton swab and kind of swirling around just a little bit and see what you get after the dishwashing liquid starts to make the contact with the milk. So pause this video, go to the Edpuzzle, and go to this video, surface tension experiments, and then come back to this video. I'm getting ready to show you this particular experiment. So see you in a few. So you've seen the video, and I thank my son for being nice enough to record me in it. Go to Kid Blog. Now, after you have watched the experiment, answer these questions. Number one, what happens to the food coloring when I first put it in the milk? What happens? Number two, what happens when I add a drop of dishwashing liquid? Number three, what direction does the food coloring move when I first add the dishwashing liquid? Number four, what direction does the food coloring move after the experiment has been going for a while? Is the milk still moving? Number five, does the movement go on forever? What happens? And number six, what happens if when I add another drop of dishwashing liquid after the color stops moving? What happens? So answer those 6 questions on Kid Blog and then come back to this PowerPoint. Let's continue. Now that you have submitted your responses on Kid Blog, let's discuss what happened in this experiment. This is how it works. Milk consists of a lot of different types of molecules, including fat, protein, sugars, vitamins, and minerals. If you had just touched a clean swab to the milk, not much would have happened. The cotton is absorbent, meaning it's attracted, it takes things in. So you would have created a current in the milk, but nothing would have really happened. But when you add something like the dishwashing liquid to the milk, there's several things happens at one time. The surface tension, the detergent lowers the surface tension of the liquid, meaning it blocks it. It keeps it, it makes the food coloring flowing free throughout the milk. The detergent reacts with the protein in the milk, altering the shape of those molecules and set them in motion, meaning they start to move around, swirl around, and make those pretty pictures or those pretty patterns. The reaction between the detergent and the fat forms micelles, which is how detergent helps to lift grease off of dirty hands, dirty dishes, whatever. That's why it gets the grease off of things, and water by itself will not do that. Now, the pigments in the food coloring gets pushed around. A pigment is a color. Our skin has pigments. Colors have pigments. You can actually make it a mixture because you can actually separate color, but we'll talk about that later. Eventually, equilibrium, which is a balance, is reached, but the swirling of the colors continue before it actually stops. So if you notice in the video, when you first put it down, you start to see, and remember, if you notice the picture in myself, I didn't have to swirl it around first. The food coloring does what it's supposed to do. It splits those particles apart. It does not allow them to stay snuggling. And because the food coloring is so light, it doesn't have a lot of density, it's able to now freely move around. It doesn't have surface tension blocking it. It doesn't have those molecules blocking it from moving freely, and it makes all those pretty patterns. So let's brainstorm. Would water work to create the swirls of color? So go on your kid blog and cite your evidence. Do you think we can do the same experiment and we could use water and you still get those patterns? Now here's an extra activity. Number one, you could try it with water and let me know on kid blog if it actually works. Here's another activity that you could do. You can make a magic milk experiment with paper. So step one is to actually try it. Step two, remember, you've made what I have made, if you're doing it or if I'm doing it, we already have our pretty pattern. So that would be our print for step two. Step three, take a piece of paper. If you don't have any construction paper, you can use Xerox paper, whatever, newspaper, whatever kind of paper that you can see it. Newspaper probably won't work as much because you already have print on it. So try to find something that doesn't have any writing on it. Dip that paper in your solution. I hear a vocabulary word again. Dip that paper in your solution. What do you have a solution of? You have a solution of food coloring and milk. So dip the paper in your solution. Then count to five. You can count to 10, whatever you want to count to, but count to at least 5 or more. Take it off and let it dry. And you start to see on this paper, you start to see the pattern that was in your milk solution. That pattern is now on your paper. Okay, so if you did the experiment, if you didn't do the experiment, you can't answer it. Okay, so if you did the experiment, will water work to create the swirls of water? If you did the experiment, you got your pattern, what I'd like for you to do, if you can, take a picture of it and upload it to Edmodo, or upload it to, your parent can upload it to Kid Blog. And then I can share those pictures with everybody, I can share them either on Kid Blog, or I can share them on Edmodo, or I know I can share them in Google Classroom. And I may actually use Google Classroom, but anyway, if you make the pattern, upload it to me. You can upload it to me in Google Classroom, or at Moto. It's probably going to be easy for you to do it in Google Classroom, but whatever. Upload it so I can share it with your classmates. Okay? So I hope you enjoy this experiment.